I've got another momentum problem for you. It's actually two problems. It's the same problem, but in one dimension, just along a line, and then in two dimensions. So same problem, first in one dimension, then in two dimensions. And we'll see how momentum works in 2D. 3,000 kilogram truck moving rightward with a speed of 5 kilometers an hour collides head-on with a 1,000 kilogram car moving leftward with a speed of 10 kilometers an hour. The two vehicles stick together and move with the same velocity after the collision. Determine the post-collision velocity of the car and the truck. All right? This is a lot like that linebacker problem we just did. Okay, what do we have? Yeah, it wasn't a linebacker. What was it? Fullback? It was a lineman. Maybe a fullback too. I don't remember. Okay, 1,000 kilogram truck moving rightward with a speed, okay. Oh, 3,000 kilogram truck moving rightward. Okay, I get make this bigger. Okay, so we have a 3,000 kilogram truck moving rightward with a speed of 5 kilometers an hour. And I stop and I say, man, units. Let's convert that. What do I get if I convert that to meters per second? I get 1.39 meters per second. Doesn't seem very big. Okay, and it's going to collide with the car moving leftward, and the car is 1,000 kilograms, and that was at 10 kilometers an hour. So it must be twice that, 2.78. Yeah. 2.78 meters per second. Oh, left, negative. And then they stick together and they go some direction. We want to know what is this final velocity. Okay. All right. I'm just going to use the equation method. I'm not going to do the table method just to make this a little bit faster. All right, initial velocity has to equal final, I just said the wrong thing. Initial momentum has to equal final momentum. I've got two objects, so momentum of the truck would be m truck v initial truck plus m car v initial car equals m truck v final truck plus m car v final car. And something I often like to do when I have all these subscripts is just make sure that I didn't mess anything up. You know, truck, car, okay, masses look good. This should be initial, both of these should be final, truck, car, okay. I think I got my subscripts correct. Now, anything zero? Nope. All right, let's put our numbers in and see what we get. Mass of the truck, 3,000. Times my velocity, positive 1.39, plus the mass of the car, 1,000, negative 2.78. Oh man, these are long equations. Mass of the truck, that was 3,000. V final truck, plus car's mass, V final car. Okay, looks like we have two unknowns, V final truck, V final car, but they stick together, which means the final of the truck is the same as the final of the car. And if you want to be lazy, you can just go erase. And now we have an equation with only one unknown. Grab your calculator and let's see what you get. When I solved this, I got a final velocity of positive. This would be pretty small, right? Yeah. Okay, this should be a really small number with those being pretty small to start with. 0.35 meters per second. So the truck wins the push. They keep going to the right, which, yeah, at 3 times the speed, at 3 times the mass, but only half the speed, that makes sense. So that's what I get. I hope that's what you got. And that's just a straightforward 1D, 2-object collision problem. Now we're going to do the same problem in 2 dimensions, where we've got them coming from 90 degrees to one another. All right, now the problem is, same 2 vehicles entering an intersection. The truck enters from the north and the car from the west. They collide and stick together. What's their final velocity? Okay, truck's coming from the north, car is coming from the west. So I've got an intersection and the truck coming in like that. The car coming in like that, so I'm doing a top-down view. and then in my final condition, they stick together, truck and car, and you know that they're going to be going this way somehow. I don't know if it's going to be like way up this way or way down that way, but they're going to be going down and to the right, because we've got down, we've got right. When they stick together, that's what's going to happen. Okay, so now this is 2 dimensions, and just like with forces, we treat the horizontal and the vertical separately. We have to treat them entirely separately because they don't interact with each other. We live in a 3D world, and our 3 dimensions don't interact with each other. So what that means is, instead of just saying this, now I say P initial in the x direction equals P final in the x direction. P initial in the y direction equals P final in the y direction. It's the same process, the same math. All you have to do is kind of separate out everything that's happening in the x direction. Only treat the x direction here, and then separate out what's in the y direction. Only treat the y direction here. So what does it look like? Okay, so we're having the mass of the truck, V initial truck in the x direction. Yeah, talk about subscripts. Plus mass of the car, V initial car x direction, equals mass of the truck, V final truck x direction, plus mass of the car, V final car in the x direction. Okay, and again, I like to stop and make sure I got my subscripts correct. Mass of the truck, mass of the car. Masses look good. These should be initial, these should be final, everything should be in the x direction. I think I got it. Okay. So I'm just doing the x direction right now. What do we have? Okay, now we do have zeros here, because the initial velocity of the truck is all in the negative y direction. The initial velocity of the car is all in the positive x direction, which means the car has no y and the truck has no x. Okay, is the truck moving left, right at all to start? No. 0. Is the car moving left, right to start? Yes. Truck and car are both moving. They have a component to the right in the final condition. So I have 1 0. Better than none. What is my math going to look like? All right. Mass of the car, that was 1,000. And this is now a positive value, and that was 2.78. I don't remember. Is that 2.78? Yes, it was 2.78. Okay, 2.78 equals mass of the truck, 3,000. V final truck in the x direction, plus mass of the car, V final car x direction. Whew. Now again, they stick together. So V final car equals V final truck in both x and y. They have exactly the same velocity. Okay, we've got, okay, I can just say those are the same, right? Car and truck are the same, so I can just do that. Yep, and now we just need to solve for V final x. And V final x, I get a plus 0.695 meters per second. All right, small? Yeah, that's right, because we're dealing with 2.78 and 1 point something. Okay, so that's just the x direction. Now we do exactly the same thing for the y direction. Okay, what's the y direction? Oh, yeah, so it's going to be the same exact equation with y's. So mass truck, V initial truck y, plus mass car, V initial car y, equals mass truck, V final truck y, plus mass car, V final car y. Okay, masses look good. Initial on this side, final on this side, y, 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 y. Okay, is anything 0? Yes. Can you figure out which one is 0? Think about it for a minute. One of these 4 terms is 0. We can ignore it. Think about that, and think about that. Is the car moving up, down initially? Is there any initial up, down motion of the car? Nope. 0. three terms, just like this. It's going to be mass of the truck, 3,000 times the initial velocity of the truck, 1 point something. What was it? 1.39. Oh, but be careful here. Got a negative sign. Negative 1.39 equals mass of the truck, 3,000, and then I can combine these again. 3,000 V final Y plus 1,000 V final Y. Solve that. Get your calculator, solve that one, see what you get. You'd better get a negative, because we know this thing's going downward. So, negative something, and what do we get? I get 1.04. Negative 1.04 meters per second. All right, I have two answers. I have a V final X is about 0.7 meters per second. I have V final Y is about negative 1 meter per second. Am I done? Have I answered? What is the final velocity? I haven't yet. I have the components of the final velocity, but that's not the final velocity. I just know how much in this direction and how much in this direction. What do you think I have to do to solve for what is the final velocity? Hopefully you say, put them together into a triangle. That's what we should do. So let's do that. All right, my horizontal velocity is positive, so I have something going to the right at 0.695. My vertical velocity, negative 1.04, down 1.04. So that is, there are my two components. What is the actual answer? That, my dear friends, is my actual answer. V final right there. I need to know how big it is and what its direction is. So to get how big it is, a squared plus b squared equals c squared. Use the Pythagorean theorem. And you should get a final velocity. You know it's got to be bigger than either of those, so I'm going to guess maybe, I don't know, 1.3, 1.4, random guess. 1.25, not too bad, a little high. 1.25 meters per second, but again, velocity, we need the size, the speed, and the direction. How do we get the direction? Well, okay, I know all three sides of the triangle, and I need to know the angle. Pick your favorite trigonometric function, sine, cosine, tangent. I prefer tangent myself because these are the two values that I know to start with. This I calculated, so you know there's going to be some, there are more digits there, I guess. So I'm going to say that the tangent of theta is opposite over adjacent, 1.04 over 0.695. To get the angle, you remember how to do this? It's not divide by tangent. It is the inverse tangent, arctan. Inverse tangent of 1.04 over 0.695. Oops. And if you do that, what do you get? I get 56 degrees. Now, what does that 56 degrees mean? If you just told me 56 degrees, that would be wrong. Because if you just say it's at 56 degrees, I say, okay, go from the positive x-axis up 56. That would be up and to the right. We're down and to the right. Multiple ways you can describe this angle. You can say it is 56 degrees below the positive x-axis. So that means positive x-axis looks like this, and 56 degrees below. Yep. Hi, Bodhi. You can say it is at negative 56 degrees. You could say it is at 360 minus that, positive 304. Yeah, got it right. Positive 304. Or you could say it's at 56 degrees south of east. So we go east and then go south 56 degrees. Any of these are perfectly valid ways to describe that angle. But you can't just give me that because it's not right. So you need to give me more information than just what that angle is. Where is that angle? So the answer we're looking for, the final velocity of the combined car-truck mess, is 1.25 meters per second at positive 304 degrees. So I'll just use that one. So is it reasonable? Definitely. We had, what did we have? We had a 1 point something and a 2 point something, a 1.39 and a 2.78. So we're in that right range, and it's in the right direction. We anticipated it would be down and to the right. It is down and to the right, so I think we got it. All right, so there is a two-dimensional problem. A little bit easier because, you know, we did have a couple zeros that we didn't have to deal with. We also didn't have to figure out what angles these were at and what their components are. So that is the next step in doing 2D problems. But this is your starter 2D problem. I hope this was useful. I hope it made sense. Good job for watching.